Welcome back, everyone. Hopefully you guys got some nice rest while we were flooded. Quick shout out to Nick M, Matt and Syed. This note sheet is about solving over a given interval. We're solving for our angle, basically, is what's happening here. First thing you need to know is what interval notation is. Basically, when you see a comma b, those are your starting and end points of what you're solving over. The parentheses means it's not included. So for example, a comma b with parentheses means I want everything in between a and b, but I do not include. So not include means parentheses, whereas brackets mean you do include it. So the difference between this one and this one is that I'm going to have everything from a to b, and I can have a and b in my final answer. If you see something like this, that means that we do not want to include a, but we do want to include b. And all this means is negative infinity to positive infinity, they're always used with parentheses. You never do brackets with those because it's not a number. You can't include a infinity symbol. So, but basically to go from negative infinity to positive infinity, that means we're dealing with all real numbers. Okay. The other thing you have to know about this section is that theta versus x. Alright, when we're dealing with theta, we're doing the problem in degrees for this section. And you can kind of tell by looking at the interval too, it'll be in degrees. Problems with x means we're going to do it in radians. Okay? So, this is kind of like trig chapter 1 where you have to solve, except for there's a little bit extra to it. Alright, so let's think about this. Solve the equation in the indicated domain, give an exact answer, and show work. So right away, let's look at the domain. It says that we're between 0 and 360, including 0 and 360. So let's just solve this as we normally would. Again, you want to get your trig function isolated. So we have 3 tangent of theta is equal to root 3, positive root 3, and then you divide by 3. So tangent of theta is equal to root 3 over 3. Now we just talked about this one on whatever day that was. I don't even know. It was last day or 2 days ago, because we were talking about the sum and difference formulas and how there's one angle that you want to use with tangent and one of them that you don't. Remember, the 30 degree is the one that gives you the root 3 over 3, because that's 1/2 over root 3 over 2, which is at 30 degrees. This is something you should just know. 60 degrees for tangent is equal to root 3. 30 degrees is root 3 over 3. So if you know that, then we pretty much know what our answer is. But we have to look at all the answers that are from 0 to 360. So I'm going to draw my circle, like we used to do all the time. And I have a 30 degree angle here. So I have 30. Now remember, tangent goes an extra 180, and it's the same 180 degrees away. So remember, the other place that it's positive tangent is when x and y are both negative. So this is a 30 degree reference. So my two answers are theta is equal to 30 degrees, and then this angle is a 180 plus 30 and 210. It's basically asking where is the theta, where's tangent of theta, root 3 over 3. So we're doing unit circle stuff again, but before we do that, we have to solve. You can double check if you go back around the circle another time. You're past 360, so we're done. We can't do any more. These two answers are in between my numbers, and we're good to go. Alright, number 2. Again, we're in theta, so we're in degrees. First, divide by 2. Alright. Now, before you can't do anything with that 35. It's stuck in there with the theta. What you have to do, though, is think, when is the cosine 1/2? So I'm going to draw my unit circle again. Cosine is x. So at a 30 degree angle, cosine's long. It's root 3 over 2. So that means that cosine is positive 1/2 at 60 degrees. Now, cosine is the x value. So I need to find the other place where the x value is positive for 1/2. And I go down here, because x being positive is in the right direction. So here are my two angles, 60, and then if you go all the way around, you get 300. So I get, when I cosine inverse this and cosine inverse this, that's basically what you're doing, you get two possible answers, like we always do. We get theta plus 35 can equal 60, or we get theta plus 35 is equal to 300. But we're not done now. That's basically the angle, that's basically what this has to equal. This has to equal either 60 or 300 based on our circle. But it's theta plus 35, so that's not what theta is. You have to subtract. And you get 25 degrees, and I should say 265 degrees. And sure enough, those are my two answers that are between these numbers. There might be another one. Here's how you check if there's another one. Go all the way around the circle, and we're at 360, plus another 60 is 420. So just check. Check that theta plus 35. The next time that will happen will be 420. If you subtract, you get theta is equal to, what is that, 385? Okay, is 385 within our interval? No, it's not. So we can't use that answer. You can always check more to double check. Alright, so cosine x sine x equals sine x. Well, naturally, here's what you guys do. You try to cross off the sine x's and go, oh, cosine x is equal to 1. However, if you do that, you are not going to get the answer. Okay, you cannot, I repeat, you cannot cancel out any term that has an x in it. It was like when we were dealing with factoring in chapter 5 and solving. You need all the possible solutions. So let's move this over. So never cross anything out with an x when you're trying to solve something. Move it over and factor. What can I take out of both pieces? I could take a sine x out, and I'm left with cosine x minus 1. Zero product property, I have sine x equals 0, and I have cosine x, when I move that over, equal 1. Now we're in radians, so just double check when you're done that you're in radians for your answer. So sine is 0, so that's when y is not happening here. Where are the possible places on our circle where y is 0? Well, it would be at 0, right? And it would be at pi. Now, here's the weird thing, though. Our interval for this one is from negative pi to 0. So negative pi, let's think about where that is. That's actually over here, too. Negative pi is over here. But isn't that the same place as pi? Yes, it is. So really, we're going from negative pi to 0, not including 0. So, for this answer, I have this one and this one. However, can I use the 0 as my answer? And hopefully you guys look at the interval and say, well, no, we're not including the 0. So this one's not an answer. It's just this angle here, negative pi. So, x is equal to negative pi for this piece. Now let's look at the other piece. Cosine of x is equal to 1. Well, there's only one place on the circle where cosine is 1, positive 1, and that's over here, the same place where sine x is 0. Okay, at the 0 again. But so let me just write out all the answers for this. You know, you could have done all these answers for the blue one. Sine is 0 there. And then for the cosine, x is equal to 0, 2 pi, 4 pi, negative 2 pi. I'm just going around the circle. But this spot, these all are the same spot. So you look at all the answers that fit in your interval. Negative pi works, 0 doesn't included, and everything bigger than 0 doesn't work. 0 doesn't get included, and none of these are included either. So the only answer that works in our interval here is negative pi for this whole problem. Alright, let's do 2 more today. Actually, what I'll do is I'll do all of these, but you can stop after we get to 5. I'll do 6 and 7 in class. So number 4, we have cosine squared theta equals 3, 4 cosine squared theta equals 3. So we take this, we divide, and then you take the square root of both sides. Remember, when you take the square root, you get plus or minus, so don't forget that. So cosine of theta is equal to plus or minus root 3 over 2. All right, let's think about that on our circle. When x is bigger, that's a 30-degree angle. So I'm going to just mark out where this could be, and it could be anywhere at the 30s. So it could be here, it could be here, it could be here, and it could be here. Those are all my x's that are root 3 over 2's. All right, but now look at the interval. Again, the interval is the key. Always go to your interval and go, okay, I need to be at negative 180 to 180. All right, so that means I'm going to go around the circle this way and then go around the circle this way to get my answers. Okay, so if I go this way, the negative direction, I get a negative 30. I also get a negative 150. If I go further, I get a negative 210. That's not my interval. I don't care about it that way. So I'm done. Let's go the other way now. My answer is 30 and positive 150. Again, if you keep going in the positive direction, you get to positive 210, which is not in my interval. So these are my 4 answers based on my interval. Again, the interval tells you which form I want the answers in. Because technically, if I would have said 0 to 360, then it would be 30, 150, 210, and 330 as my final answers. But because I gave you an interval from negative 180 to 180, the interval is, or these are your 4 answers. All right, number 5, all real numbers. Okay, first of all, if I'm saying all real numbers, that means I'm going around the circle multiple times, which means we need our favorite letter back, K, to represent our revolutions. This is almost like an arc, little arc problem. So, first things first, you have to move everything over and factor. So, again, no canceling anything out. If you cancel, you did something really wrong. Alright, so I take out a tangent, or I'm sorry, a cotangent. Then I set everything equal to 0. And when I do that, I get this equals to 2 actually. Now turn these back into sines and cosines because we don't know these values. So cotangent is just what? It's cosine over sine equals 0. So all we really care about then is cosine being 0 because we want a 0 on top of our fraction. And over here, if I flip these, if it's cosecant equals 2, that means the sine has to be 1 over 2, the reciprocal. And now I can do these problems. So for the cosine, we already did cosine of 0. Cosine of 0 only happens, no, actually that's not true. We did cosine of 1 earlier. Cosine of 0, when x is 0, that's up here and down here. And again, we are in degrees because it's a theta. So I have 90. Okay, and I have 270. Now, hopefully you guys realize, remember with cosine we did 90 plus 360k and 270 plus 360k, but this is the one time where instead of doing that, if you guys notice what happens, it just repeats itself every 180 degrees, just because it's at the top and bottom. This is the only time that happens. So for cosine, I can say that theta is equal to 90 degrees plus 180k, because it'll happen every 180 degrees around the circle. Now, I'm going to do the other one, where sine is 1/2, positive 1/2. So I'll do a circle here. 1/2 is a very small angle, so that would be here. It's 30 for y, which means that this is also 30. Okay. This one I need 2 answers for because it doesn't repeat every 180. The first one is 30 degrees, so theta is 90 and 180. It's also 30 degrees plus 360 because it'll take us 360 to way back to around to that part. And then we have the other theta is 150 plus 360k. So these are all our answers for this one. I know it's a lot, but It's good to have them. Alright, so you guys can stop the video now. I'm going to keep going and finish up this video with the last two, but we will do the next two in class. So, you can turn it off now, and I will see you later. Alright, if you stayed with me, we're back here. Still factoring, still solving. So, when in doubt, factor. Again, no canceling. Take out a cosine. And also note our interval is from negative 180 to 180, but we are not including those, so we can't count any of those answers. Alright, so we have cosine of theta is equal to 0, and we have negative 1/2. So cosine of theta equals negative 1/2 when I solve that. So let's do the first circle. For 0, again, when cosine is 0, we're up at 90, and we're down here at negative 90. Again, when you see an interval like this, that means we're starting at 0 and we're going this way up to here and this way, and you want to name your angles with those in mind. So, for this problem, cosine's at 90 or 270, but we can't call it 270. We'll call it negative 90 instead. So theta is equal to 90 and negative 90. And that's all that I get out of that part of the problem. Now I'm going to do this part where cosine's negative 1/2. Negative 1/2 is a smaller angle in the x direction, so it's right here. It's a 60 there, and it's a 60 there. I should probably not draw that in. I don't need to draw those. Yeah. Alright. So, there's cosine is negative 1/2. So figure out, again, where we're at. Again, go from here to here, and go from here to here. That's what this interval is telling us to do. Name the angles that way. That's all it does. So we have 90 plus 30 is 120. So theta equals 120 degrees. And it probably is the same thing the other way. If you go negative, it's negative 120. And those are all your final answers. We have these 4 answers for this problem. We'll solve that. Okay, last one. 0 to 2 pi. Alright, this looks like a Batman type of problem. I'm going to just guess and check, but you can use Batman for it, / splitting the middle term. Pretty much, in order to get a positive 2 but a negative, these both have to be minus. I think this has to be the minus 2 because we need a minus 5. Just quick a double check. 2 sine squared minus sine minus 4 sine gives us that positive 2. Alright, so I've factored that correctly. Alright, next step, set each piece equal to 0. So if I set this piece equal to 0, I get a sine x equals positive 1/2. And if I set this piece equal to that, I get sine x is equal to 2. Now, hopefully you guys realize that this isn't possible. Because remember, on our unit circle, you can never have an angle with sine where the ratio is bigger than 1. So if you did this in your calculator, and these, by the way guys, if you need help with all of these, you know how I'm just getting them? You can start off by using your calculator. Do second sine of 2, and that'll give you undefined. Alright, so, anyway, this doesn't work. This one will. So we're just going to go around here. 0 to 2 pi, we're not including 2 pi. So sine of 1/2, positive are those two. This is where you have to be careful though, because we're in radians. So I have, it's a 30-degree reference, 30-degree reference. 30 degrees is the same thing as pi over 6, not pi over 3. So that means this is 5 pi over 6. And that's it. So my answer is x is equal to pi over 6 and 5 pi over 6. Alright, and that is it. I'm just going to double check. You guys can turn the video off now. I feel like there was one that I might not have answered correctly. No, I did do that one correctly. Alright, that is it. I will see you guys in class.